Okay, so we're going to be starting to talk about direct variations this week. So for homework, I want you to watch this video, and then you'll have an IXL assignment to do over the weekend. So direct variations look like this. They look like simple equations. All right, so y equals kx. So we could think of something that varies directly. So when one thing increases, the other thing increases. So here's an example. The amount of fun you have, oh, this was made by another teacher. He liked to do origami. So when he was not doing origami, he was not having that much fun. But when he was doing origami, which is like paper folding, he was having a lot of fun. You can think of other things like that. Something that you enjoy doing directly varies with the amount of fun you're having, okay? So let's look at an equation. So again, this looks like y equals kx. It's always going to be called the constant of variation. And sometimes we need to find what this number is going to be that is helping it vary directly. So here's an example. Y varies directly with x. Find the constant of variation if y is 24 when x is 8. So I like to just set up my equation, y equals kx, and just put in our numbers for our variables. So since y is 24, we're going to put that in there, and x is 8, we're going to put that. So to solve for k, you're just going to divide by 8, and then we scroll down here, and then we see that k, these are going to cancel, so k is equal to 24 divided by 8, which is 3. So basically our constant of variation, you can write the equation over y equals 3x is the equation. All right, let's go and look at another one. So here's the formula for an inverse variation. That is not a direct variation. Inverse means that it's the inverse of multiplication, right? So if a direct variation, you're multiplying k by x. In an inverse variation, you're going to be dividing k by x. So let's play around with that a little bit and look at that. So you've got, this is what an inverse variation looks like, okay? The amount of school we go to is inversely proportional to the amount of snow we have, right? If we have a lot of snow, we don't go to school. If we have a little bit of snow, like a little tiny bit, we might be in school. If we have a lot of snow, probably not going to be going to school. All right, so it goes and avoids the origin, whereas a direct variation goes through the origin. So let's play around with this. We've got an inverse variation. All right, so I got the steps out for you. In an inverse variation, y is 13 when x is 2. So let's write out our equation for an inverse variation. It is k divided by x. Oh no, I'm sorry. Yeah, it is. It's k divided by x. So we're going to find k. Let's put some numbers in for x and y. So y is 13, so let's put a 13 in. We don't know k, but we know that x is 2. Okay, so let's go and solve this. Now look, you're going to multiply both sides by 2, and so k is going to be 26. So if you really just wanted to know what k is, you could just multiply your x times your y. That's pretty much the formula for finding k on that one. All right, so then you got to go back and write the equation with your new k in there. So this is basically y equals 26 over x. All right, when you go to graph that, it is going to be a very spread out looking inverse variation, okay? Remember, it doesn't go through there. Nope, doesn't go through the origin. All right, so let's go find one more. Here's another formula. Assume y varies inversely. All right, so now we're going to have to go find something else. We know y is 8 and we know x is 2. So let's go find our variation. So here's our equation. Y equals x over k. No, I'm sorry, it's k over x. All right, k over x. Plug in our variables. So 8 is equal to k over 2. Multiply both sides by 2, and we get 16 is equal to our k. Well, that's not quite what we need, all right? We need to find the equation, all right, when y, we want to find the y when x is 7. So now we've got k, we don't know y, we don't know what our y is, but we do know what x is in the new one. I'm going to change my color. So now I'm going to rewrite my equation. Y equals, now K is 16. And in our new one, where we're trying to find when it is 7, we do that. Well, that's not really going to reduce, so that's fine. That's really just, what is that? That's going to be 2 and I think 5/7. I'm sorry, 2/7. Okay, so it's not going to be a number that we're going to be able to see a whole number. So let's just leave it as 16/7 because that's easier to see. All right. Let's see what else we got. All right, time needed to complete a task varies inversely as the number of people, right? More people you have, the less time it's going to take. So it takes 5 hours for 7 men to install a new roof. All right, well, how long would it take 10 men to complete the job? So here it says inversely, so we're going to use this formula. Y equals K over X. All right, so let's take our first numbers. We've got 5 and 7. Okay, how did I know to put 5 in for hours? Remember, X is always time. Okay, so whenever you see time, put that in for X. So let's go plug that in and see what we get. What is our equation that tells us how long it's going to take to do this? So 7 is equal to K over 5. All right, and then we're going to work this all out, multiply both sides by 5, and it looks like 35 is our K. Not quite done, that's just the factor that we're using, right? Now the next question, how long, we don't know how long, so that's our X, right? Would it take 10 men? 10, so we're going to put a 10 here. Plug these points into our equation, so Y equals K over X. That's our inverse variation formula. We're going to plug in 10 for Y because that's Y. We're going to plug in 35 for K, so 35 over X. This one's a little harder to do because X is in the denominator. So let's multiply both sides by X and we end up with 10X equals 35. And now we got to go and divide by 10. All right, so once we get that done, we get 3.5. That basically says it's going to take 3.5 hours for 10 men to complete the job. All right, so we're not going to go through all of these. We'll look at combined variations later when we go and combine some things where you're going to do a direct variation and an inverse variation. But what I'm going to have you do is an IXL. I'm going to go through all this. And these are the things we're going to do next week. I want you to go to IXL and go to Algebra 2, Q7. And what I want you to do is work on that until you get about 70%. Okay? And that's going to be your assignment for the day. All right, have a great day.